Hello everyone. Today's problem is nCr. This problem is having the difficulty medium level, but this is a very easy problem. Given in the problem, given two integer values n and r. The task is to find the value of binomial coefficient nCr. A binomial coefficient nCr can be defined as the coefficient of the x raised to r in the expansion of 1 plus x raised to n. That gives the number of ways to choose the r object from the set of the n objects without considering the order. The binomial coefficient nCr is calculated as nCr C n r is equal to n factorial upon r factorial into n minus r factorial. Note here r is great if the r is greater than n, return 0. Okay, here given examples, n is equal to 5 and r equal to 2. The answer is 10. The value of 5c2 is calculated as 5 factorial upon 5 minus 2 factorial into 2 factorial is equal to 10. This is the given example. Let's understand on the board. We know the formula for the nCr is formula for the nCr is, let's change this. nCr is n factorial upon n minus r factorial and r factorial. This is the formula for the factorial. This is the formula for the binomial coefficient, means nCr. This is a formula for the nCr, and by using this formula we have to calculate the given this is a given formula, and we have to calculate the now what's given. We have given change the pen color, 5c2. okay, so 5 factorial divided by 5 minus 2. 5 minus 2 is 3 factorial into 2 factorial. How will we solve it? It becomes 5 into 4 into 3 factorial and 3 factorial into 2 into 1. Okay, so 3 factorial cancel, 1 cancel, 2 into, okay, 2 to the 4, 5 into 10 equal to 10. So this is the answer. Yeah, see, so this is the answer. This is how we solved it. Okay, now let's understand the thought process and approach behind it. Okay, this is going to the thought process and approach. Now, what brute force you can think of? Yes, there is simple brute force. No, what we have given the nCr. We know the formula, n factorial upon n minus r factorial and r factorial. So here given is a factorial, here given it is a factorial, and also here given it is a factorial, here given factorial, here it is factorial, here factorial. So we can write the separate code for the factorial and then call the factorial function for this, and return this. It means store this in variable and return this, and we know we write the recursive code for the factorial. So this we will write for this and this. This is a very easy approach and time consuming approach. You can try by yourself. We will see the optimal approach of this. So what can be the optimal approach for this? We know what we know. We have to calculate. Let's see. We have to calculate like this, means we have to calculate nCr, means let's take 5c2. We know we are going to calculate 5 into 4 and 3 factorial, and 5 minus 2 is equal to 3 factorial and 2 factorial. We know we are going to expand this n only this much time, r much time, means we have to run the loop only r time. Let's see we will do, means we will expand this n until we get the n minus r. What I said, we will expand this n until we get n minus r, until we get n minus r. After this, what will happen? We will cancel both of them. Yes, we will cancel both of them. Okay, so what will be left? There will be n and 2. So how many time, how much times we expand n? We expand that this times, this much time, this much time. So we will run the loop only r times, and calculate this and simultaneously divide by this. Let's take the another example. Let's take another example. See, if we take the 7c4, okay, we know we are going to expand 7 only r times, let's see how it happens. Okay, so 7 factorial. Okay, let's write denominator first. 7 minus 4 is equal to 3 factorial and into 4 factorial, which is r. So we have to expand this n this times, n minus r times. Means until we get this, we have to expand n this times. Okay, this times r times until we get the n minus r to cancel it out. Okay, then we will expand it like 7 into 6 into 5 into 4 into 3. Okay, this will get cancelled out now. This will get cancelled out. Can you see? We have the 4 factorial as r. Okay, we had the 4 factorial as r, and we expand n only 4 times. So this is clear that we have to expand the numerator n only 4 times, so we will loop over the r and calculate the simultaneously. This is very easy code, and this code only consists of some arithmetic operations only. So let's see the code directly. Okay, this is the given code. This is the given code. The given in the question itself. If r is greater than n, return 0. We are doing the same. If r is greater than 0, return 0. If r is equal to n, return 1. If you know in the nCr, when both r and n are same, the answer becomes 1. How it is? When 2c2. Okay, 2 factorial upon 2 minus 2, 0 factorial into r, which is 2 factorial. So everything cuts out, remaining is 1. So when both r and n become same, then answer becomes 1. So it is clear that when both become same, we have to return the 1. So we are directly returning it as a 1 here. We are directly returning as a 1. This. And when the condition like this is the extra condition which is not added, which is not required, but I am adding to save the time complexity and time to run it, which is says that when it is given like that 32 c 31, we know answer will be 32. How? 32 factorial, 32 minus 31 is 1 factorial and 31 factorial. So we will expand it like this. Okay, so this will and this will get cancelled. 1 factorial will be 1, so answer will be 32. So we will have to return the 32. So what I said in the condition, when r is equal n minus 1, means r is 31 is equals 32 minus 1 means 31. So we have to return n. We have to return 32. We have to return 32. This condition, this says that. Okay. So now we have taken one answer variable here to store the answer and return after performing the action. Okay, here the answer variable we have taken, and this is the loop. We are going to run only r times, as I said, only r times, because we are going to expand the n only r times to reach n minus 1, n minus r to cancel it out. So we are running the loop from 1 and less than equal to r. Every time we are multiplying with the n. every time we are multiplying with the n and simultaneously decrementing it, and also we are dividing by the I. This all gives us the nCr. This gives us a nCr, and we are storing is the long, and then we have to return the int, so we are typecasting here and returning the answer. Now let's see the dry run of this. Suppose it is given like 5c2, so n is 5 and r is 2. Okay, let's check the first condition. If r is greater than n, no, r is not greater than n. First condition fails. If r is equal to, no, also wrong. If r is equal n minus 1, also wrong. Now take the long answer variable, answer equal to 1. Okay, uh, let's take in the empty space for the clearer view. N is equal to 1. Okay, now we start the traversal. I equal to 1, answer is equal to answer into n. What is n? N is 5, so we'll multiply the 5 with it, so it becomes 5. Okay, and we are decrementing the n, so n becomes 4. Okay, now we decremented it, and then we are doing this. Answer is equal to answer divided by I. Answer divided by I is 1, so divided by 1 becomes 5 itself, so no need to write this. Okay, when I becomes I equal to 2, when I equal to 2. Okay, now I became equal to 2. Now what to do? Answer is equal to answer into n. What is n? N is 4, so we are multiplying 4, so it becomes 20. Okay, it becomes 20. Now decrementing the n, and it becomes 3. Okay, after that we are dividing answer by I. What is I? I is 2. I is now 2 here. Now I is 2. I is 2 here. Okay, I is 2 here, so we are dividing it by 2. So it becomes 10. So this is after doing all this. Now our I reaches to the limit. I is equal to r. R is 2, so we will exit the loop. And after that, what our answer hold 10, we will typecast into int, and we will return the int. This is this much simple code. Okay, this is having the time complexity of big of r, because we are running the loop over r times, and big of, are we using any space or what? No, we are using no space, so big of 1. We are using only we are using the space for variable, so it is negligible, so big of n. Okay, so this is the time complexity, and this is the space complexity. Now let's run the code. This is the code. Now let's this test case is passed successfully. Now submit the code. Yes, all test cases are passed successfully. Both the C++ and Java code given in the description. Subscribe for more. Thanks for watching. Bye.